All right, so happy Thursdays. It is that time again where we do weekly webinars, and lately we have been doing a deep dive in neuroscience. Last week we learned about Parkinson's and how the different reward pathways and kind of contribute to the different regulation of those chemicals in our head. Now we're going to take a bit more of a general look. And why do some things make us happy? Why do some things make us sad? Why do we get addicted to some things? Why do people with ADHD seek that little kind of rush, and while others do not? Hopefully, we might be able to understand that a bit better today. Oh, nice. Oh, and wants to motivate herself. Well, we are going to be learning about what motivates people today, and knowing that, interestingly, chocolate is a drug. So we're going to be talking a bit about that as well today. So most of us are probably drug addicts, but don't worry, we're going to be learning that chocolate isn't as bad as, say, heroin. So there is a difference. Oh, Joe, how to get more dopamine when I need it. Okay, well, I guess you could learn that as well. But we will also learn that too much of a good thing is a bad thing. If there's not enough dopamine, bad time. Too much dopamine, bad time. You've got to get that sweet Goldilocks amount. That amount of dopamine is just right. I'm Nat, for those who do not know, and I'm the head of community at Exceptional Individuals. I deliver the educational content, which hopefully upskills people. And with that, I think we are finally ready to get started. So as specialists in dyslexia, dyspraxia, autism, ADHD, you might be thinking, why are we even bothering with this reward system? Well, it obviously affects everyone, but predominantly ADHD. That is why we're going to be taking a bit more of a deeper dive today, because ADHD, as we know, is about attention, being hyperactive, and these are all interweaving with dopamine. And it's normally where the brain isn't able to get the fix. Often people think ADHD is having too much dopamine, but often it's about not having enough dopamine, or the brain not being able to reabsorb or uptake the chemicals that it released in the first place. So this is why people get a bit confused when they learn about medication. Oh, Adele says, I am a neurodivergent mum with a neurodivergent son, so keen to learn much more as possible. Thanks so much for hosting this event. You're very, very welcome. Now, our team is predominantly neurodivergent, so we're experts via experience, but we're also trained in it as well. So we come at it from a multiple different perspectives. Now, the last webinar we did, which we do every single Thursday, we did Parkinson's and the brain. And I know you think like, nah, Parkinson's, what does that have to do with neurodiversity? Well, actually, if you look at a lot of these brain disorders, they're not so different. Sometimes it's just a little bit too much dopamine there, not enough serotonin there, a little bit of GABA here and there. Like the difference is quite minor, but the effects can be quite different. Or sometimes the effects can be quite similar. So by learning about these different conditions, you might have a more well-rounded view about why the brain does what it does. I won't lie, last week was a bit more difficult. This week, hopefully, will be a bit more of an easier ride, but if you did attend last one, this one will definitely complement it. So, the reward system of the brain. Now, most of us have heard of dopamine thinking, oh yeah, it's that feel-good chemical. No, it's not. It relates to it, definitely. It's a reward chemical. Well, is it? You know, there's a lot of kind of misconceptions and myths about this. And the more we understand about it, the more we're able to manipulate it and make it work to our advantage. So let's start off with a nice question. How do you reward yourself? Sorry for the gif. I thought it was funny. So how do you pat yourself on the back? Do you say, okay, I'm going to do a bit of work right now, then I'll treat myself to a muffin, maybe do a bit of exercise, and you'll kind of relax with Netflix? Okay, we've got a bit of shopping, nice. Sweets, absolutely. I do love going to old-fashioned sweet shops. Cakes, who doesn't love them? Booze, eating, relaxing, food, nice. So all of these things, now we think we're doing this because we want to do it. But if we really start thinking about what even is free will, maybe we do not do it. Our brains are reinforcing. Every time we eat cake, we're getting that sugar, it makes us feel good. Then we're reinforcing a pathway in our brain. And next time, our brain automatically knows, yes, that's good. It's why whenever you shake your little treat jar, your cats will come running. They know because they're building up that pathway. So honestly, as much as you think this is your choice to take a relaxing bath, you've actually conditioned yourself. You've kind of manipulated your own brain. Okay, chill times, relax, still figuring it out, time out with friends and fam, a nice bit of sunshine. Brilliant. And all of these, believe it or not, are related to chemicals. When you drink alcohol, well, you're putting a new chemical in your brain, which is altering your signals. A bit of sunshine, getting that vitamin D, that's also changing the chemicals in your brain. So a lot of these is about redistributing all these beautiful chemicals in our brain. Some of them will make us feel good, some will make us feeling down. The right amount will give us that right balance. If we have too many of some, we might have an out-of-body experience, such as recreational drugs. They all have different effects. So why do we reward ourselves? Well, the concept of reward highlights how pleasure drives repetitive behavior throughout repetitive reinforcement. And if we remember rightly from learning all about autism, repetitive behavior is one of the key characteristics. So actually, this probably links into it as well. Every time the brain is repeating an action that it enjoys, it's getting a little bit of a hit from it. So first of all, we engage in rewarding behaviors. This is a very, not just a human condition, just a condition for all animals. We do something, we get rewarded for it. It makes us want to do it again. Imagine like every time you went to the park, you got kind of like stabbed. Bad example, it happened in my park recently. You wouldn't go to the park anymore. But if you go there and you have a great time, you'll probably want to return. Now, pleasure gives positive reinforcements. So a reinforcement is saying, good job, keep doing it. And the more positive reinforcements we get, the more enjoyment and happiness we get out of it. So already we're creating a pattern. Now, they use a lot of this kind of training for children to make them do what we want, but it never really goes away in adulthood. The only difference, as a child, adults will do it to manipulate you, to get you to do what you want. But when you're an adult, you manipulate yourself without even knowing sometimes. I recently, literally yesterday, I got a little Fitbit and it vibrates every time I've done enough steps. So I'm actively trying to keep fit now because for some reason I want that little buzz. And also, there are different types of rewards. You've got your natural reinforcements like food, water, sleep, sex. All these things are very natural and the body loves them. But there's also artificial rewards, such as drugs. Now, obviously, you've got your cocaines and your your heroin and your marijuana, but you also have prescription drugs. You also have chocolate. You also have coffee. Artificial drugs do not have to be kind of sinister, though they can be. There's many ways to make the body do what we want. So out of these, which ones do you think are natural rewards? I've mentioned a few of them. It's mainly to make sure you're all listening. So are kind of drugs that you might get, say, from that guy around your back alley, or from Boots, or food or water, or gambling, or sex. Which ones are natural? Now, again, with natural, we're talking it from a scientific perspective, not just like what you think. You might think, oh, gambling's natural. I think I'd argue not, but okay, let's see what the correct answers are. So, okay, anyway, well, drugs are, in terms of the ones that you might take yourself, not natural. Artificial. Food and water, absolutely natural. It's one of our primary things we do to keep alive. Gambling, not natural. Games, social media, internet, that essentially is a type of gambling. It rewards you for taking a risk. People love taking risks. And one thing you will know, that those with ADHD have a higher level of risk tolerance. Often they will purposely go out their way to be a bit more risky because it helps them feel good. And what we will learn about a little bit later is the more you take a drug, the less effective it is. And we know that, right, from taking drugs or from hearing other people take drugs. But what we don't realize is that also happens through natural rewards as well. If you eat too much food, then you're not going to feel as good. You're going to have to eat more food to feel better again. If you get a bit of gambling, well, The first time you win, you're going to feel amazing. The second time you win, meh. And then you can see how it kind of, the return of reward gets diminished more and more and more. So while we can manipulate the body, it's not something we should do continuously, because it kind of leads into addiction, and you can literally get addicted to anything, any of the things, through drugs, food, gambling, sex. Anything which rewards the body can also punish the body if we don't monitor it correctly. So how does good food make you feel? So when you have a really nice bit of food, just let me know, what type of like emotions or feelings or responses do you get? And once again, food is a drug because it releases chemicals in your body, depending what chemicals you have. So let's say if we have an apple, it might not make you feel amazing at the start, but it will release chemicals throughout the day, and you'll get kind of a good balance of chemicals. You have yourself a cheeky Macca's, and you're going to feel great in the moment because you are ODing on like sugar and salt and all these random chemicals you have no idea on. But then you're going to have a massive drop, and then you're going to feel bad. So essentially, we regulate our chemicals. And if you have a natural, healthy diet, you might not feel that instantaneous boost, but you will last longer. Or if you have, say, some sweets, you're going to feel good straight away. Now, the body, we love it. It loves to feel good straight away. It doesn't like hanging around. So once again, you can see how the brain can get addicted to things that aren't particularly good for us. All right, we've got satisfied, euphoria, that's a nice word, energized, calm, relaxed, healthy, fulfilled. I think it really depends on the type of food you eat, doesn't it? For me, whenever I eat McDonald's, I feel great in the moment, but I feel instant self-pity straight after. When I eat a nice salad, I'm like, yeah, it's all right. But I genuinely feel better throughout the day. So in terms of natural rewards, you've got food, water, sex. These are the ultimate primal things. You know, this isn't just for us, it's for all of the animal kingdom as well, even plants, I suppose. We must do it to feel good. And essentially, the way that we survive as human beings is if we do something and it makes us feel good, we'll do it again. Imagine if we ate food and every single time it made us just want to be sick. We wouldn't eat and we would die. So it's a very, very natural process. Pleasure. Pleasure is a great thing. We do it because it feels good. You know, truthfully, there's many, many things in life which are good for us, which do not bring us pleasure, and we do not do them. If you can find something which kind of joins the both, it's a win-win. Then we've got behavior reinforcements. You want to. So let's say you've done a hard day's amount of work, you'll reward yourself with watching some TV after. If you didn't have some way of rewarding yourself, you would struggle to have that motivation to do that thing which doesn't come natural to us, which in our modern day is quite a lot of things don't come natural. Okay, Helen says, can we add things like being clean, warm, etc. to our natural rewards? Absolutely. If it's something which you feel that you need as a bare necessity, which those things are, absolutely. I will say though, for some, well, maybe not warm, but for some people don't like being clean, but mostly yes, ultimately it is. And then behavior repetition. If we want to create a routine or a pattern or something which we do time and time again, maybe this is waking up early, maybe it's eating healthier, maybe it's exercising, being better organized. We can only create those circuitry and patterns in our brain if we have found a way to reward it. So please do not go out your way trying to be more organized. If you're a disorganized person, absolutely hate it. You have to find a way which works with your kind of natural reward system. If it doesn't work in the natural way, you might go to artificial, but obviously natural's better if possible. So what I want you to do is rank the natural rewards that you respond best to, because there are different ones. Some have better benefits. So if you're like, yeah, water, love it, you give it like a number 1. If you think physical touch, not that bothered about it, you might put it as 6. So we got food, water, sex, nutrition, physical touch, and sleep. Okay, sleep, it's always sleep, isn't it? We love a good bit of sleep, mainly because we're probably sleep deprived as a society. Food, Nice, yep. Love a good bit of food, water, nutrition, sex, physical touch, all very, very essential. Now, for different people, they'll have different things which are more essential to them that will bring them more joy. And people will say ADHD and depression, these kind of the things which kind of refill their kind of like goodness is different for everyone. This is also the same why certain drugs have different effects on different people. Now we've talked about the basics. We've talked about basic rewards. Now let's get into the science of it. And now we might be able to understand how this really relates to us as human beings. Now, I've talked about it before and I'll talk about it again. Let's talk about the good old neuron. These are the brain cells in our head. We have hundreds of thousands of millions of these little critters. They are cells in the brain that talk one to the other. You've got your nuclei, you've got your dendrites, you've got your synapses, you've got your axon, you've got your myelin sheath. Essentially, a signal of electricity will go, and when it gets to the end, it will send chemicals out. So it's electricity, chemicals, electricity, chemicals, electricity. And these things are how our brain communicate. And this is going to be essential because what we learned from our previous episodes is if one thing can go wrong, it's going to affect everything. But it could be anything. Maybe your dendrites, little things at the end, aren't catching the chemicals very well. Maybe the nuclei isn't formed correctly. Maybe the myelin sheath, the kind of insulation, isn't working right. There are so many different things that can go amiss. And because it's so tiny, how do we ever know what's going wrong? And this is why in medication, it's not about finding out what's wrong with you. It's about finding out what's not wrong with you and doing process of elimination. So within this neuron, if we were to zoom even further, at the very end, we have the synapse. So here you've got the synapse and it connects with the dendrite. So one end connects with the other end. But as you'll see here, they're not actually joining. There's this little gap. And this is called the synapse cleft. And this is the little section where chemicals go from one to the other. And these little chemicals, they could be dopamine, they could be GABA, they could be serotonin. There's lots of different chemicals that they could be. But today we're going to focus once again on dopamine because that's one of the primary chemicals which help us with reinforcement, with pleasure, with motivation. All characteristics which a lot of people who are neurodiverse often struggle with. So here is a close-up image of this kind of gap between the synapse and the dendrite. So as you see here, it gets to the end and then there's a gap. So a neurotransmitter is just a fancy word for a chemical. Neuro, brain, transmitter, like sending a signal. So it will send a signal. And then you've got receptors. These are like the baseball gloves that will catch the signals and bring it in and send it along. If everything's working perfect, back and forth, back and forth. So chemicals will go, they'll be absorbed. If some chemicals are left over, they'll be resucked back up again and sent again. This is how things work in a perfect environment. But let's say you have too much dopamine, too much chemicals, then the receptors are overloaded and it's taken too much in. Let's say your receptors are feeling lazy, they're not really working, then the chemicals can't be sucked up. Or maybe the kind of recycling mechanism, which reuses the leftovers, isn't working. So once again, if you're trying to really work out why your brain isn't functioning the way you want it to function, there's so many different things that could be going on. Is it the receptors? Is it the transmitters? Is it the reuptake? Is it the kind of what kind of releases it? Many, many different things. Now, as we mentioned, dopamine. Dopamine is one of these neurotransmitters. Now, I want you all to have a guess. Do you know which one is dopamine? Now, I don't expect you all to know, but you might have seen some of these little images before. These are just like what the kind of symbols are. They're like little bonds. And nice, yes. Oh, it is the second one. Oh, some of you voted for the third one even after I gave the answer. Yeah, don't worry. No, the other one's still going up. It's the second one. So this is dopamine. And dopamine is an interesting one. And it carries messages. It isn't just related to pleasure. In fact, a lot of science research shows that it's more related to motivation than it is about reward. So we often kind of contribute it to feel good, but it can also feel bad, and it has other functions as well. So here's a quick true or false about dopamine. You say if it's true or if it's false. So dopamine is a neurotransmitter essential for brain function. True or false? Dopamine is solely responsible for pleasure. True or false? Dopamine is linked with motivation and experiences of pleasure. True or false? And drugs like cocaine and I do know the word, I can't pronounce it.
Just say speed.
Speed. All right. Cocaine and speed boost brain dopamine levels. So let's have a look at these. Correct, false, correct, correct. So dopamine is a neurotransmitter essential for brain function. Absolutely. Without dopamine, our brain isn't working. You have to have dopamine. It is both, then the right amount, it's a good thing. Dopamine is solely responsible for pleasure. No. And this is what people used to think was true. It is purely related. There are other chemicals going on. It's just one of the primary chemicals. It is not the only one. Dopamine is linked with motivation and experience of pleasure. So once again, dopamine really isn't a pleasure chemical as much as it is a motivation chemical, but motivation is highly linked to pleasure. So maybe if you think about, okay, I'm doing this because it makes me feel good, you're doing it because it motivates you to feel good. There is a difference. So again, you're not eating chocolate because it makes you happy. You're eating chocolate because you're motivated to feel good. And as a result, chocolate is a way of getting to it. And drugs like cocaine and speed, they will boost your brain's dopamine. So we know things like exercise, food, water will give you more of a dopamine boost, but it's a small dopamine boost. But if you take cocaine, massive dopamine boost. Now, if dopamine makes us feel good or motivates us to feel good, surely we want to have lots of cocaine. No, because if you have too much of a good thing, it kind of floods the circuits and it kind of fries it. So next time you want to feel good, it's not going to work that well. So this is why, though the brain wants us to have as much as possible, honestly, we probably shouldn't. It's the same with sugar, really. You shouldn't have that much. April, yes, sorry, levels means levels. I tried to be hip and make it smaller, like on the Pokemon games, but yeah. So now we're going to look at the reward system. This is a chunk of the brain which is predominantly responsible for putting that dopamine to good use. So the reward system uses dopamine to communicate. It all starts in the VTA. That's slang for the ventral tegumental area. Up there, I put it. So that is the center part of the brain which does the good stuff. So the reward system is the brain regions, like in the VTA, that uses dopamine for communication. Does anyone know where it is? Judging by these dots? No. Don't worry about it. It's somewhere nestled around there. So let's go, it's around about there. Now, if we take an image on this one, it's here. So the VTA is this little nugget here. And you'll notice the nearer we are into the brainstem, the older that part of the brain is in terms of an evolutionary perspective. The further we get out, the more modern it is. So humans, we have a massive frontal cortex, but it's still a relatively new area. But things like the hippocampus, the VTA, the Nigeria, the striatum, very old. Now, in our brain, we want it to talk to everywhere. Now, some areas are quite far away, so we have what I like to call a superhighway. You have your kind of little country roads, and then you've got your express roads. So the black lines that you see here, these are like the motorways in the brain. If it wants to get some dopamine ASAP, it's going to take the motorway. So these black lines are everywhere where the dopamine travels. It can go elsewhere, but these are the areas. So if you do something which your brain wants to reward you for, it will then send it up to these little different pockets. Okay, hopefully that makes sense. So how do we know this? Am I just making this up? Did I copy it from Wikipedia? No, I didn't. But we learned it through a series of experiments with our friendly little critters, mice. Poor mice, but they did help us a lot. So how do we learn this about the brain? Well, there was experiments done, and we had some rats in little boxes, and they had little levers, and they had what you'd call electrodes, these little metal spikes in the brain. And every time they pushed a lever, they'd get a little buzz. But it was wired to the part of the brain, which is, we talked about the VTA. So essentially, it would zap that little area there, very, very small, by the way, and it would kind of kickstart the kind of dopamine pathway. So that sounds like a bad thing, right? To zap someone. If you got zapped, you probably wouldn't want to be zapped again. But because where it was connected, it made the mouse feel good. So the mouse would keep going back and pushing it again and again and again and again. The mouse purposely self-stimulated itself. The mouse got addicted to zapping it. So it showed here that there was a connection. Because the mouse was wired up to the exact part of the brain that we thought was linked to pleasure, it was able to be proven. But the poor mouse got addicted. So it was quite a good way of showing how, one, our theory is correct, and two, maybe we've also created a monster by creating all these artificial ways of making ourselves feel good. Now, when we talk about these artificial ways of making us feel good, we'll naturally go towards them. It's just what people do. But what do you think releases the biggest amount of dopamine in the brain? Again, I want you to rank all these. Do you think sex gives you the biggest boost? Or is it a bit of chocolate, cheeky bit of meth, a bit of cocaine? What do you think? What do you think is going to get your brain going? So we've got, okay, it's moving around. Chocolate, we've got chocolate as the number one. Oh, sex as a close, oh, no. And one thing we'll say is, when we're talking about ADHD and depression, a lot of individuals do take medication, and it's normally to kind of offset the kind of the lack of the brain producing this dopamine, or at least in an effective way. So we can either support the brain in a natural way, such as like water, sleep. We can do it in an artificial way, such as like drugs and coffee, or it could be in a deficit way where maybe the brain just isn't working correctly and isn't kind of doing the right kind of messaging, hence ADHD and depression. So first of all, we've got cocaine as the top. It's actually not, but we'll get back to that. And chocolate, sex, and meth. So let's see what the actual answers are. So first of all, meth. It is ridiculously. So when we're talking about baseline, 0 is the baseline for normal, okay? So if everything's going completely how our brain was developed, 0. So having a bit of chocolate, we talk about chocolate being a drug. Oh, I'm so naughty. Yeah, it's not really that naughty. It's 50%, not that big of a deal, but it still alters the chemistry in our heads. That is that. Then if we were to say, just have sex, that's 100%. No wonder why humans like reproducing and not reproducing. It feels good. Now, 50 and 100, this is kind of like what we expect. Anything over 100, we're getting into unnatural territories. So cocaine, 300 times normal amount in terms of our dopamine receptors getting a bit of a buzz. Now, if you take meth, which hopefully none of you do, it's 1,000 times above average. Now, if you are feeling 1,000 times better than you normally feel, you're definitely going to want to feel that way again. So why aren't we all taking meth? Genuinely, why not? I'll tell you why. Because the more you take these, go above your baseline, the harder it is to achieve it again. So for instance, 100, that's fine. But now we're kind of tipping over the edge now to like 300. Let's say you take cocaine. The first time you feel 100%, 300 times better. The second time you take it, you might feel, 250% better. And then it goes lower and lower and lower. So you get diminished returns. So if you become a drug addict, suddenly you've got to take a lot more cocaine. And eventually the cocaine just isn't working. Then you think, well, maybe I should upgrade to meth now. So when we talk about gateway drugs, it's a real thing because we get so used to certain things. So you might start off with chocolate, then you kind of like might move up to some coffee, then you might start vaping. Then before long, you're a meth addict. Obviously, I'm jumping a little bit here, but you can see how easy it is to move. Now, if you look at some nice CT scans of the brain, the normal brain here. Now, if you see the red, that is the brain responding to dopamine. Now, the more red it is, the more activation it is, and it means working great. The less red there is, the less activation. So someone with cocaine is feeling less of a buzz. And you think that doesn't make sense, right? Surely you take cocaine in order to feel a bigger buzz. But if you take cocaine more than once, you're going to get less and less of an activation. And this is the brain when it's not taking drugs. And that's a really important thing. Though cocaine might make you feel invincible in the moment, when you're not taking cocaine, that's when you're going to have less activation when your baseline is 0. And that's not good. So let's say on average, you feel okay. When you take drugs, you feel amazing. But then when you're not taking drugs, you feel awful. So you're kind of screwing yourself over in the long run. Drugs are a quick win, but they aren't a long win at all. They really do screw you over in the long term. And unfortunately, there is a connection between those with ADHD who are more likely to suffer from drug addictions, such as like gambling addictions. It's because that brain is trying to find its own kind of workaround. But without knowing that knowledge of the kind of longer implications, doom. All right, Emma says, when I was being diagnosed with ADHD, my psychiatrist especially asked me about cocaine usage and explained how it works differently with ADHD. My mum was in the room. Awkward. Yeah, it does. And this is the thing. These type of certain chemicals are, let's face it, they're universally bad. Most people agree they're bad. But if you have ADHD, it's even worse for you. And this is often what people do not let you know. One, you're more at risk becoming addicted, and two, the kind of effects on you are arguably worse. So it's good being mindful. Also, if you're obese, you also have less activation. So people often say, obesity is like a drug or effect. It also does relate. So again, consequences of drugs. What is going on? And when we're talking about drugs, we're not just talking about illicit drugs, we're talking about all types of drugs. First of all, they can lead you feeling depressed. And even if you take drugs which are to support with depression, because essentially you have less dopamine, for whatever reason, your brain's not creating the dopamine. The drugs, more dopamine. But then the brain gets used to the extra boost. And when you're not taking the medication, drop. This is why if any of you have ever been on antidepressants, I'm on them, by the way, no shame, and you're taking it and you're feeling, I'm feeling good now. This is because it's releasing more dopamine. But if you're I'm feeling good now, I'm going to stop taking my medication, you're essentially turning the tap off. And then you'll go on a massive deficit and you'll feel even worse. It's why when you come off of drugs, whether or not it's prescription, over the counter, illegal, whatever, you have to do it very carefully because you have to readjust the body. It's kind of like when you're reclimatizing after you kind of got off a plane or climbing a mountain. Okay, another thing, which is the danger, is high tolerance. So if you take a lot of drugs, and again, this is also the same for say ADHD medication for a long periods of time, it's not going to have the exact same effect on you. So whether or not you want to take something long-term or not, this is a consideration you have to take. And the tolerance for human beings is interesting because it depends on your shape, your size, and sometimes if you don't have, with ADHD drugs, it's really interesting. If you don't have enough of the drug, it has 0 effect. If you have too much of the drug, it has 0 effect. You have to get the right amount. So it isn't more the merrier. It's about getting the exact right dosage. And this is why it's so important to speak to your doctor. Next one, we've got no pleasure. So the pleasure that you used to get from taking substances disappears. You always see Americans I'm gonna take some Xanax, or they're just popping pills left, right, and center. I watch a lot of trash TV. I'm not talking about America in general, just the shows I watch. And you notice at first they take it for pleasure, and then eventually they take it out of necessity. And that kind of when it swaps from pleasure to not pleasure, it's a final, you don't notice it. It happens very gradually. And this is something you've got to be very mindful of when you're kind of using it to feel normal. So if we're taking a bit more look back into the neurons, this is what normal firing of dopamine looks like. So this is the neuron. Remember, at the end of the neurons, we've got the synapses. The synapses are sending out these neurotransmitters. And in here, if things are all working well, you get your kind of bolt electricity. It gets to the end, it throws it out, then it gets sucked in by the receptors, and then a signal is sent. And if there's any leftover, they get sucked back up. That is what it looks like when a brain is working completely normal with dopamine. But unfortunately, if you have ADHD, if you have depression, if you're on any sort of drugs, this is what it looks like. So for instance, we've got our baseline firing. Remember, baseline is when things are working normal. Baseline is good. Then we've got the bursts of firing. This is when things are all activation, go, go, go. When you take a drug, it is kind of like sending a big like nudge up the bum, and it's sending lots of chemicals at once. But after you've taken the drugs, you'll notice you've got the post-burst firing, and actually you have less firing than you do during the baseline. So yes, drugs can very well be helpful, but then afterwards, you're kind of dealing with a bit of a deficit. And this is why you've got to keep up the routine. So dopamine neurons fire in bursts after drug. Following this, the cleanup, the reuptake of dopamine is slower. So let's look at this image again. So again, when the brain is working exactly like we should, it sends chemicals out, they are taken to the other side, and the message is sent. When we've got a bit of leftover, because we always send more than we need, it then gets sucked back up again, like reuptake. You see there's a couple of dots here. When we are taking the medication of whatever it is, lots extra gets sent out, and then some of them get sucked back up again. But you'll see then there's more afterwards, there's a lot of leftover and it has not been recycled. So when it comes to sending when there's that next bolt of electricity which resends the chemicals for the next message, there isn't as much dopamine to go around because the dopamine wasn't recycled. And this is why drugs are good in the moment, but then afterwards there's a bit of a lack. So you've really got to follow when people say take it at this time, take it at this time, because if you miss that time zone, then you are going to just not be having, not only are you not going to have that boost, which you have become accustomed to, your brain is actually going to be worse than it was originally when it came to processing these chemicals. All right. Is this more noticeable in illegal drugs, e.g. come down? Yes, exactly. Thanks, Emma. That's exactly what a come down is in some regards. Your baseline is your brain went from working on hyperdrive to worse than it did before the drugs. And the come down is the brain re-regulating the chemicals. It's about saying, all right, we need a bit more of that to kind of get things back to normal. And the more drugs you take, the better feeling you feel in the moment. But the more it's going to block up your recycling center and the harder it is going to be to feel normal again. The more you know. All right, we're almost at the end, everyone. So in terms of what's happening now, a little bit of ongoing research, views on dopamine are still developing. They're changing all the time, okay? It is thought to be involved in aspects of reward rather than pleasure. This is a big difference. So when people say dopamine is a pleasure chemical, no, it's more related to reward and motivation. There is a key difference here. So reward is something which is needed in order to motivate us to keep doing something, where a pleasure is something which we feel we have more control over. We don't have much control as we think we do. The mesolimbic pathway, remember that is just like the superhighway that we spoke about, is important, but not solely responsible for pleasure. So it's not as simple as we made out today. There's a lot more going on under the hood than we give the brain credit for. And research shows dopamine is not a pleasure signal, but a signal for motivation. So rather than trying to think when you're trying to hack your brain, I'm doing this to make it feel good, think about what motivates the brain in order to keep repeating a pattern. This might help you in trying to navigate how to control your brain a bit better. A few things we touched upon today is the reward system. This is structures involved in rewarding experiences. Now, this system is made up, but it's a part of the brains which we see the most activation, not all the activation, in brain function. The VTA system is only part of the system. Dopamine is not the only neurotransmitter involved. We're giving dopamine way too much credit here. There are other neurotransmitters which are involved. Dopamine is just the most active one. The reward system is really complex. Obviously, today we simplified it. Current research aims at better understanding the reward system in disorders such as ADHD and depression. So if we genuinely want to understand ADHD and depression better, we have to understand dopamine and the reward system. They go hand in hand. But this isn't just for, this also affects, like we talked, like Parkinson, schizophrenia, psychosis. It's involved in many, many different areas. Oh, thanks, Helen. Always a pleasure. If any of you want to learn more about what we spoke about today, here is a lovely library of books and resources, which I know you'll never read, but is there in case you ever want to. Now, feel free to subscribe. If you want to watch the video, go to YouTube and type exceptional individuals. Oh, Stacey, absolutely incredible session, Nat. I am of a few more and will be recommended to my colleagues. Thanks, Stacey. Great to have you. Oh, yes, and I subscribed. Woohoo! I think we've got like 3,000 subscribers now, which is fantastic. Keep them coming. The next webinar is on fake news, and this is going to be a really interesting one. So we spoke a lot today about what people think they think is true to what is actually true. Now we're going to be diving in deep to the common misconceptions, the type of things like we only use 10% of our brain, or, you know, more guys have ADHD than women. You know, we are going to be tackling these myths head on and backing it up with science. So if you ever want to correct your friends when they misquote something, but then they say, prove it, you'll actually be able to do it now. Here is our contact details if you want to get in contact. My name's Nat, N-A-T. Just drop me an email at nat@exceptionalindividuals.com and I'll happily get back to you with any further questions. Oh, Anna says, can we have a webinar about reward discounting and future planning? Do you know what, Anna? I'll definitely put that on the agenda for next year. But if any of you have further ideas, let me know and I'll happily try and incorporate it into future sessions. All right, that's a lot of talking for me today. We finished a little bit early, which is always a pleasure. I hope you found today useful and see you next week. Thanks, everyone.